This second video has to do with chapter 8, where we discuss confidence interval estimates. Back in chapter 7, we talked about sampling distributions, and we came up with a formula, or an adjustment to our z-score formula that used a standard error of the mean or a standard error of the proportion. This adjusted formula goes into our confidence interval estimate formula we use in chapter 8. So let me kind of explain, maybe with an Excel spreadsheet, kind of what's going on here. So this is the first example in the book, example 8.1. And basically, we can do confidence interval estimates for any measure in a population. But in this chapter, he does means and proportions, which are the center lines. And so for our mean, basically, you have two situations that can arise. The first one, which was example 8.1, you really don't see, but you need to know how to do the computations anyway. But anyway, and he uses terms in the book that are always confusing to students. He uses known standard deviation and unknown standard deviation. This has confused students for years. So let's see if we can't kind of explain what those mean. So in the first situation, if you have what's called a known standard deviation, that means that you have historical information about your process or whatever it is you're dealing with, and you are willing to use that historical information to estimate what you think the standard deviation is. So when you take your sample, you don't do a computation, you use what you think it is. If you do it this way, you can use a normal distribution. And if you do it the other way, which is, when you say, okay, I really am not willing to make that leap of faith that I know what it is, and I'm going to actually compute it using my sample, then you use a different distribution. But it's always a confidence interval estimate for the mean either way. So the difference is in the distribution that you use. So for this first example, they are making paper, and the paper is supposed to be 11 inches long and has assumed to have a standard deviation of 0.02 inches. Remember, sigma and mu are population figures. We'll never know whether those are exactly right or not. We just assume that, that's what we want from our population, that this is the standard deviation is what it does. Anyway, so we take our sample. We take a sample of 100 sheets of paper. We compute a sample length from those, which is 10.998 inches, which is not the same thing as 11 inches. It's close, but not exactly. So what we're trying to do with this confidence interval estimate is to take this sample, and using some confidence interval that we have picked out, we try to determine whether the mean that we think is in our population was actually within our interval or not. If it's not, then we know we've got a problem with our production process. So anyway, this is kind of leading us into chapter 9, where we do hypothesis testing, but we'll get to that next week. Anyway, so the confidence interval. You pick the confidence interval. In this chapter, for this particular problem, he says use a 95% confidence interval. And that is kind of a standard for most business applications. I think when you're using PHStat, it comes up automatically if you're using a larger stats package than Excel, like SAS or SPSS or Minitab or JMP or one of those packages. It's automatically assumed that you want a 95% confidence interval, and you have to manually go in and change it. So remember our distribution, and we talked about doing a symmetrical range around the mean of 95%, I think back in chapter 7. And I think you did it in chapter 6 also. So if you have a 95% confidence level, your alpha level is 1 minus 95%, or 5%. And since we assume it's centered around the mean, half of that is in each tail end of your distribution. This is the reason we use the notation down here in our confidence interval formula that says z-value for alpha divided by 2. In this case, it would be a z-value for 0.025. or 2.5%. Anyway, and you remember how to look that up. So if you were looking it up in your normal distribution, you would go and you look up the area 0.0250 and find the z-score that goes with that, which in this case should be a negative 1.96. And I left the negative off, but that doesn't matter. So what you do, there are kind of two parts to this. There's the X bar. This is your basic sample data, plus or minus the z-score for alpha divided by 2 times the standard error of the mean. That's sigma divided by the square root of n. So the part that comes after the plus or minus is something called a margin of error. You've all seen this. If you've been watching election polls and things on TV, they'll say somebody's got, our polling shows somebody's going to get, 49% of the vote with a margin of error of 6%. This is the part that comes after the plus minus. It's the size of the spread around this mean that you should expect to find in your real population. So we've got our sample 10.998 plus or minus, again the z-score, we're by 0.025, divided by my standard deviation, which I assume the 0.02, and then the square root of the sample size, which was 100. So I end up with a confidence interval of 10.998 plus or minus 0.0039. Again, this 0.0039 out here on the end is my margin of error. You can also state it by subtracting the 0.0039 from the 10.998 to get a lower value and an upper value. You can do this in Excel using PHStat. So if it's easy to do it, go to PHStat and confidence intervals, and they've got both our situations: estimate for the mean sigma known, and estimate for the mean sigma unknown, and estimate for population or for proportion. We won't do the variance. Anyway, sigma known, my population standard deviation is 0.02. Confidence level is 95%, so you just have to change it if you don't like that. And then sample statistics known, we don't have a file for this. So my sample size was 100, and my sample mean was 10.998. If you had an actual file, then you would click on this and tell it where the range was. And then you just say, okay. And it should pop up with a confidence interval, which is the same one I think that we got before. So a lower boundary of 10.99 inches, I think we got 9941 on my calculator, up to 11.0019, which is slightly above, but this shows right out because it only goes out 2 decimal places. So it's easy to do it with PHStat, which makes a lot more sense to me. Anyway, so that's how you do it in PHStat. And remember, the size of the margin of error is very much dependent on the confidence level that you choose. So 95% would give you one number. If I chose a 90%, I would have had a 1.645 in here. And if I chose 75%, I'd have even a different number. So it's important to think about the confidence interval. Anyway, that's if example 8.1, if you're going to estimate the population standard deviation. If you do it computed from sample data, I think this is the file here, insurance. I'm pretty sure that's it. Anyway, they gave you a file, I think, in the book called insurance, and you can do it directly with PHStat from there, but I've already looked at it. And so if you have the data already given, again, you go through the same thing. The difference being that you'll see down here where we had a z-score for alpha divided by 2. Here we've got a t-score for alpha divided by 2. This is the studentized distribution in the back of the book, right after your normal distribution. This distribution has something called degrees of freedom in it, and maybe you did run into it before, I can't remember. But anyway, you would look up the value in your normal distribution. I'm trying to find it in here so I can look at it, just make sure I'm telling you exactly right. It covers a couple pages. Anyway, so across the top, you'll see the cumulative probabilities in blue, and upper tail is in a purple color. And if you have a 95% confidence interval, you're going to look for the 0.025, the middle one there. And 0.025, yeah, you're going to look for the middle one. And then your degrees of freedom. So you read down that column until you get to the degrees of freedom, which is your sample size minus 1. So our sample size in this case was 27. So I would look on the row that says degrees of freedom are 26, and I read across until I get to the 0.025, and I should see 2.0555 in my book. I think I left one of the 5s off. Anyway, that's how you use the t-distribution. And then this is just the standard error of the mean again, except that they've now used the standard deviation from the sample, so it's called S instead of sigma, still divided by the square root of n, and you still end up with a confidence interval estimate that has your mean plus or minus your margin of error, which in this case is 10. Again, you can use pH-stat for this, confidence intervals, sigma unknown. I shouldn't have done it on this page. I'm sorry. Let me go. Let me go to the file. So here's my data. It's in the insurance file. I go to pH-stat and confidence interval, sigma unknown, and 95%. And I'm going to click on this sample statistics unknown and select my range of cells. So this is insurance times to do insurance claims or something. And this box is checked because I did select the time, the title in the first column. So then I just say OK. And this should give me my upper and my lower boundary for my confidence interval. So it's 33.89 to 53.89. And you can see, if I go back to chapter 8, that's the same thing I got when I did it by hand. Okay, so anyway, that's how you do those two. And then the other thing is a proportion. And it works kind of the same way. You have to figure the standard error of the proportion, which is this p times 1 minus p over n. You still use a normal distribution. And you figure your p-bar. So in this case, my sample size was 200. This is example 8.4. My proportion, they had 35 whatever out of the 200, so their proportions is 17.5%, and they want a 90% confidence interval here. So half of 90% subtracted from 100% is 10% divided by 2, which is 0.05. And if you look that up, you'll see that 0.1645 there. So anyway, I put my numbers in solve, and this is my confidence interval, 0.175% plus or minus 4.42%. And again, you can state it also in this form down here with the things subtracted off. And again, you can go to pH-stat. You can do it just as easily here for the proportion. Your sample size is 200, and number of successes, that's where your 35 goes in, and you just say okay. Oh, I did it wrong. Let me go back to pH-stat and confidence intervals. I did the wrong one. I didn't change it, which is something you have to be careful with. So sample size was 200, number of successes was 35, and I want a 90%. So I just changed that to a 90% from a 95 and say okay. And this should be exactly what we got when we did it by hand, which was 0.1308 as a lower boundary up to 0.2192. And our margin of error is, let's see, our margin of error is, this is it. It's called interval half width. This is your margin of error right there. So if you're asked about that, you know where to find that also. Anyway, so that is how you would do that one. So it's easy to do. The calculations are not hard. And then the only other thing left in here is determining sample sizes. And there are formulas in the book, example 8.5 and 8.6. And basically, when you're looking at determining sample sizes, this formula, if you're getting ready to do a study and you had no idea how big a sample you needed to match some confidence level with some amount of error you were willing to accept, then you would look at using a formula like this. So this is the formula for the sample size when you have a mean, and this is the formula for the sample size when you have a proportion. So in this case, we want a confidence level of 95%, which means my z-score is 1.96. The amount of error, this is whatever I'm willing to accept. So obviously it says 4 and it gets squared, and then the sigma is assumed to be 25. So it ends up, whatever you get, you have to round it up to the next whole number. So I would need a sample size of 151 to give me a large enough sample to make sure I'm satisfying this 95% confidence level. And the same thing for the proportion. The strange thing in the proportion is, so here's my 1.645 for my 90% confidence level, and I'm assuming an error of 0.05. And in this example 8.6, they say if you don't know what the proportion, that shouldn't be there, in the population is, I'm going to try to fix that. There. Okay, I'm sorry, I found a mistake. My typing is not so good sometimes. If you really do not know what the proportion in the actual population is, use 50%. That gives you the largest sample size. If you estimate the proportions actually 35% and then that's off, you'd be wrong. So this kind of takes care of, any sort of problem you run into. So again, you get 270.6 and you're going to increase that to the next whole number, which is 271. So anyway, that's how to figure the sample sizes. Anyway, I hope this helped, and let me know if you need some more assistance. Thank you.